This resource is the second in a four-part series on graphing trigonometric functions. Part 1 looks at the graphs for the two fundamental trigonometric functions, sine and cosine. Part 2 considers the various features of the sine and cosine graphs. These features are defined, and methods for finding each are presented with an example. Part 3 suggests using the features of the general sine or cosine as stepping stones for graphing a general trigonometric function. Part 4 looks at the graphs of the other four trigonometric functions formed from ratios involving sine and/or cosine. Let's take a closer look at the graphs for sine and cosine we developed in the first installment of this series. There are certain features of these graphs that will become important. The maximum for each graph is +1, and the minimum is -1. For both graphs, it takes a full 2 pi radians to complete the cycle, or for the graph to start repeating itself. We can think of the y-intercept as a starting point for the graph, even though it repeats endlessly in both the positive and negative directions. The sine graph has a y-intercept of 0. The y-intercept for the cosine graph is its maximum, 1. But how can we generalize these features? The features of a trigonometric function can be defined based on its equation. We will use a sine function as our basis, but the definitions are exactly the same for a cosine graph. Suppose we have a generic sine function, y equals a times the sine of the quantity bx minus c plus d. The features we will consider first are the amplitude, the frequency, and the period. The amplitude is the maximum value for the function. It can be found by taking the absolute value of the a value, whatever the trigonometric word is being multiplied by. The frequency measures how many cycles are fully completed in any 2 pi distance. This value is b, or the coefficient for x. A related feature is the period. While frequency is how many cycles are completed in the space of 2 pi, the period determines what distance in x you must travel before the cycle repeats. The period is found by dividing 2 pi by the value b. There are two more features we must consider for the sine function. While the amplitude and period stretch the graph, it may also be translated, or slid around the plane. We will consider the phase shift and a vertical shift. A phase shift translates the graph horizontally. In other words, phase shift moves the graph left or right. To find the phase shift, divide the value for c by b. Note that the c is being subtracted. This means we need to switch the sign we see to its opposite. A vertical shift moves the graph up or down. It is exactly the value for d. Let's see an example. Suppose we have the function y equals -3 multiplied by the sine of the quantity 2x plus pi plus 4. We want to find all the features of the graph of this function, namely the amplitude, the period, the phase shift, and the vertical shift. First, we will find the amplitude. Recall that the amplitude is the absolute value of the a value, which for this function is -3. This results in our amplitude equaling 3. Next, we will find the period of the function. By definition, the period is 2 pi divided by b, so we will have 2 pi divided by 2. Our period is therefore pi, and the function completes a full cycle in half the x distance required for the basic sine graph. The phase shift is found by dividing the c value by the value for b. In our function, we see a plus pi inside the parentheses, so our c value is actually negative pi. Therefore, our graph is shifted by a negative pi divided by 2. In other words, our graph moves by the quantity pi divided by 2 to the left. The vertical shift is simply the d value. Since we have a plus 4, our entire graph shifts up 4 spaces. How will we use these features to graph a general sine or cosine graph? Stay tuned for part 3 of the series.